Everything around you has been optimized. Your groceries arrive overnight. Your maps reroute instantly. Your packages move across continents in days. Decades of engineering made modern systems faster, cheaper, and tighter than at any point in history. So why does everything seem to break at once? In late December 2022, Southwest Airlines unraveled under a winter storm and cancelled nearly 17,000 flights in just over a week. Millions were stranded. But the storm was not the real problem. The real problem was a scheduling system so stripped of redundancy that once disruption entered the network, there was no slack left to absorb it. Then, in 2024, a single software update from CrowdStrike crashed millions of computers worldwide in under 2 hours. Flights grounded, hospitals froze, banks locked up. Not a cyber attack, not sabotage. One routine configuration update pushed globally without staged testing or network isolation. These systems didn't fail from bad engineering, they failed from one-dimensional optimization. And that exposes the trade-off. Efficiency is not resilience. In many cases, it is the systematic removal of slack. And slack is not waste. It is the invisible architecture that keeps complex systems alive. Look at how modern institutions measure success. Boards reward lean operations. Markets punish idle capacity. Quarterly earnings favor immediate yield over long-term durability. So redundancy gets reclassified as inefficiency. Spare inventory is minimized, backup crews are cut, secondary suppliers disappear. The margin for error gets stripped out because slack doesn't show up on a balance sheet. And for a while, the system looks brilliant. Costs fall, speed increases, investors celebrate, executives get promoted. But something dangerous is happening underneath. The system is losing its ability to absorb shock. When every component locks directly into the next, friction disappears. But so does the ability to absorb shock. A delayed shipment stalls a factory. A factory outage starves a supplier. A software glitch spreads instantly across globally synchronized systems. Failures no longer stay local, they cascade. That is why modern breakdowns feel different. A single disruption can suddenly freeze entire networks because the system was designed with no space between its moving parts. And the dangerous part is that fragility stays invisible until the exact moment it becomes catastrophic. Years without failure convinced leaders the cuts were rational, but they did not eliminate risk. They concentrated it into single points of failure. Single vendors, single routes, single scheduling systems. The system runs flawlessly until it encounters a variable it was never designed to handle. So here is the shift. The problem is not efficiency itself. The problem is optimizing for only one dimension, cost, speed, or margin, while treating resilience as waste. The systems that survive shocks best are not the ones that abandon efficiency. They are the ones that build deliberate slack alongside it. Backup pathways, modular failures, cross-trained teams. Systems that can degrade gradually instead of collapsing instantly. Engineers have a name for this: graceful degradation. Not maximum performance under perfect conditions, continued function under imperfect ones. That changes how you read every headline about outages, shortages, or institutional breakdowns. You stop asking who made a mistake and start asking what redundancy was removed, and who decided it was unnecessary. Because in a world obsessed with doing more with less, the most valuable systems may no longer be the fastest ones. They may be the ones that survive.